Hello, this is Mrs. Pullen for Algebra 2 Midterm Review. In this video, I want to go over a couple of problems involving the end behavior of polynomial functions. So let's review the four cases. In order to determine the end behavior from a polynomial expression, you want to find the term containing the highest exponent. So let's take a look at this upper right box. We have an expression x to the fifth plus 3x squared plus 1. The term containing the highest exponent is x to the fifth. We notice that the highest exponent is 5, and that's an odd value. And we notice that the leading coefficient is 1, which is positive. So from that, we can determine that the ends of the function are going to go in opposite directions, and the right side is going to go up and the left side is going to go down. In other words, as you go to the left, as x approaches negative infinity, as you go to the left, your y values are going down, and as you go to the right, your y values are going up. Now let's look at the next case, the one right below. So an example would be y equals negative x or y equals negative x cubed. The term containing the highest exponent, let's take a look at this one, is negative x cubed. So we know that n is 3, a is equal to negative 1. So n is odd and a is negative. When that happens, the ends are going to go in opposite directions. The left side is going to go up and the right side is going down. In function notation, we'd write approaches negative infinity. In other words, you're going to the left. Y values are going to go up. As x goes to infinity, as you go to the right, your y values are going down. It's a good idea to write these notations because sometimes it could get confusing. Okay. Now let's look at the next case. Suppose we have something like y is equal to x to the fourth plus 3x squared plus 1. So let's take a look at the term containing the highest exponent, which in this case is x to the fourth. We see n is 4, which is even, and we see a is equal to 1, which is positive. Well, because we know n is even, both ends are going to go in the same direction, and because they're positive, they're both going to go up. In other words, as you go to the left, as x approaches negative infinity, you're going up, and as x approaches positive infinity, you're going to the right, and y values are going up, so up, up. And then the last case, which is directly below on the left side, let's take a look at y equals negative x to the fourth plus 3x squared plus 1. So n is 4, a is negative 1, that's even, with a negative leading coefficient. Notice because if it's even, they're both going down, and they're both going in the same direction, and we know they're both going down because of the negative. So as x approaches negative infinity, as you go to the left, y is going to a negative infinity. In other words, you're going down. As x approaches positive infinity, as you go to the right, y approaches negative infinity. You're going down. So that's a summary of the four cases. So let's look at the examples. So here we have a polynomial, and we look for the term containing the highest exponent. So n is equal to 3, which is odd. A is equal to negative 1, which is negative. So I know that they're going in opposite directions. And because it's negative, the left side goes up and the right side goes down. So just be careful. All of these are to the right. So as you go to the right, you're going down. So it can't be this one. As you're going to the right, you're going down. So it can't be 1 or 3. So it has to be either 2 or 4. So as you're going to the right, you're going down. And as you're going to the left, you're going down. Well, that's not correct. So let's look at 4. As you're going to the right, you're going down. And as you're going to the left, you're going up. So that's our answer. Let's look at number 27. The highest exponent is x to the 5th. N is equal to 6. A is equal to positive 1. So that's even with a positive leading coefficient. That means both ends are going in the same direction and they're both going up. And if we look at the choices, number 1 is right up and left up. So it's choice 1. Let's skip to the number 29. You're given a polynomial, and from that we have to examine, find out which of the following statements are true. Is the degree of the function even? And that would be correct because we see that both ends are going in the same direction. So it's an even degree. So it can't be choice 2. Is the leading coefficient negative? No, we see that both ends are going up, so we know we have a positive leading coefficient. Let's skip to odd and even functions. That's different than odd or even degrees. So, in order for a function to be odd, not only does the highest term have to have an odd number, an odd exponent, but all the exponents are odd. In order for a function to be an even degree, an even function, not only the first or the leading term has to have an even exponent, but all the terms have to be even. If there's a mixture, then we say that the function is neither even nor odd. So let's take a look at the first expression. We see with this function, we have an even, so we know we have an even degree, but because x to the first 1 is an odd, it's neither because it's a mixture of exponents. So that's neither. Now let's look at the next expression. Here n is 3, here n is 1. We know it's an odd degree, but it's also an odd function because all the exponents are odd. Graphically, we can tell if something is odd or even, or if odd if it's symmetrical with respect to the origin. That means if you flip the graph upside down, it looks the same right side up as upside down. And it's even if the function's symmetric with respect to the y-axis. Well, we see this is not symmetric with respect to the y-axis, but we also know that this is not symmetric with respect to the origin. If I turn this graph upside down, it's not going to look the same upside down as right side up. So I'm just tracing this. Let's see if we can do this. So I'm going to go upside down. Wait, that didn't work. Hold on. Let's try this again. Here's my function. And let's try to flip this upside down. So let's see, flip up and down. And we see that it's not the same. So it's not, it's not the same. So it's not odd and it's certainly not even because it's not symmetric with respect to the y-axis. So this is a neither. And the last function we know is even. It's symmetric with respect to the y-axis. So this is symmetric y-axis. And let's do, the last one I'd like to do is number 33. So you're given a polynomial expression, but notice there are no numbers in it. They want you to sketch the graph, and they tell you that A, B, and C are positive values, and that A is greater than B. They also tell you that P of X has a positive y-intercept, and we need to label all intercepts. So the first thing, I want to find out the end behavior. So I take the first term in each expression and I multiply it out, and that's my leading coefficient. N is equal to 3, and A is equal to 1. So it's odd and positive. So that means the function is going to rise to the right and fall to the left. Next, we want to get our x-intercepts. So we set each of our linear factors equal to 0 and solve. And we get x is A, x is B, and x is negative C. So we're going to graph that. So negative C is the only one on the left side of the x-axis. But here's where you have to be careful. We know A and B are both on the right-hand side, and we know that A is greater than B. That means A is to the right. And D, the y-intercept, is positive, so it's above the x-axis. Okay, so now we have enough information to graph this. You have to show these labels. You're going to lose points if you don't. Okay, and we start left to right. It passes through negative C, passes through D, cuts through B, and cuts through A. And we're going to put arrows on the end. And that's how you would do that type of problem. And I actually want to do one more. I want to do number 34. So they ask us to create an equation based on this graph. And they want it to be represented as a product of linear factors. So what do I notice? I notice that one root is at -4 and one root is at 5. But actually, the root at -4 is tangent to the x-axis, so that means it has a multiplicity of 2, whereas the root at 5 cuts right through, so that means it has a multiplicity of 1. For this particular problem, we are given enough information so we can get the exact equation because we know what the y-intercept is, 0, 40 are the coordinates of the y-intercept. And so I can find my leading coefficient. So this is going to be something A times x plus 4, because minus and minus 4 is x plus 4, squared times x minus 5. That's the real general equation. And now, since we know the y-intercept is 40, so that's p of 0, and that's x is 0, right? So this is going to be 40 is equal to a times 0 plus 4 squared times 0 minus 5. So 40 is equal to a times 16, because 4 squared is times 16 times -5. So 40 is equal to -80a. And I divide both sides by -80. I get 40 over -80, which is -1/2. So now I can fill in, and I get p of x is equal to -1/2 x plus 4 squared times x minus 5. Have a great day.